All right, well, hello everybody. We are going to go through how to run an independent samples t-test in SPSS right now, which is part 3 of chapter 7. So hopefully you have with you your textbook and access to SPSS. And let's see if I can get this to, right there. This is pages 97 through 100 in your textbook, and we're just following along with that example. And the data set is the same data set that we've been using for all of chapter 7. Lucky us, the zombie data set. So we've got that same zombie data set you'd want to open up. And in terms of what we are doing for this independent samples t-test, we're interested in two groups consisting of different people. We're going to be using the first and second column in our data set. What we have here are, and let me get here to that, change it. These are the zombie attitude questionnaire, right? These are people's attitudes on humans' attitudes about zombies. And this column, chased, is was that human being ever chased by a zombie or never chased by a zombie? So this gives us two separate groups. We've got people who were chased by zombies at some point in their life, and those who were never chased by zombies at some point in their life. And so you can see we've got two groups that we're comparing, and we have different people in each group, and we're interested in their opinions, this zomb variable, opinions on zombies. Okay, and we're ignoring the second column. This was the column for time 2 after participants had their sensitivity training, but we're not doing that. We're just looking at their initial feelings about zombies and if that's related to whether they've been chased by a zombie before or never chased by a zombie before. I don't know, I'm going to take a wild guess and say, yep, that would affect my opinion on a zombie. So we're interested in two groups consisting of different people. One group of humans who have never been chased by zombies, so that's the chased group. Who have been chased by zombies, that's the chased group. And one group who have never been chased by zombies, that's the never chased group. And we're interested in whether average attitude towards zombies, and that's that zomb variable, is different in humans who have been chased by a zombie compared to those who have never been chased by a zombie. And so we're using that dependent variable, that first column, zomb, representing humans' attitudes before they attended any kind of sensitivity training. As always, we start with our hypotheses. The hypothesis is, the null hypothesis is that the mean attitude towards zombies for group 1 would be equal to mean attitudes about zombies for group 2, or using the more descriptive subscripts, the null hypothesis is the mean attitude towards zombies for those who are chased would be equal to the mean attitudes towards zombies for those who are never chased, right? The null hypothesis is there should be no effect of the independent variable, which in this case is being chased by a zombie or not. And so the two groups should have equal attitudes. The alternative hypothesis is that the mean for group 1 will not be equal to the mean for group 2, or, this should be a 1, not a 0, that the mean attitude towards zombies for those who have been chased by a zombie will not be equal to mean attitudes about zombies for those who have never been chased. Okay, so now it's time to run our t-test. Let me go over here real quick and reset the whole thing. Okay, so we've got our data. We go to Analyze, Compare Means, Independent Samples t-test. So we're comparing means of two groups, and they are independent groups, different people in each group, so it's an independent samples t-test. The group variable, in this case, excuse me, that is my cell phone. let's see, the grouping variable in this case is what are the two groups? And then for us, it's this ever chased by zombies before. This is our independent variable. It goes here to the grouping variable, right? Chased. And then you've got to click here to define your groups. And what we had used was a 1 and a 2. I'm actually going to cancel this for a second and show you back here, right? We had entered the data with 1s and 2s. And so that's how SPSS is going to divide your two groups. So analyze, compare means, independent samples. We're using our independent variable or our grouping variable, ever chased by zombies, moving it here into the grouping variable. You have these two question marks, which you have to get rid of. Define your groups, and we're using group 1, that's the chased. Group 2 is never chased. And then hit continue. And our test variable, that's our dependent variable. In that case, it's this first zombie variable, the zombie opinion measure the first time, not the second time. We're interested in the first time. We can hit OK. And it's as simple as that. Brings us down to our statistics. Here's our group descriptive statistics. This is important to know that when you have an independent samples t-test where you have different people in each group, you can actually have different number of people in each group. In this case, we have 14 people chased by zombies and 16 who have never been chased by zombies. And that's fine. You don't need to have the same number of people in each group. Whereas for a paired samples t-test, you do, right? Because everybody in the first group has to be the same as everybody in the second group. It's a pre-test, post-test design. So for paired samples t-test, these numbers will always be the same between your groups, but not the case with an independent samples t-test. It's okay to have different numbers of people. Here's our mean in terms of their zombie attitudes, standard deviation, and standard error. Remember, on the zombie opinion measure, we always look at the top row and ignore the first two columns that are the Levine's test for equality of variance. Pretend it's not there. So here's our T of negative 2.61, 28 degrees of freedom, which is you add these two numbers together, which is 30, and then minus 2 gives you 28. Here's our significance, 0.014. And if I said to test this at the 0.05 level, which is the most typical level, we're comparing 0.014 to 0.05. And because this 0.01 is less than 0.05, we have a statistically significant difference between the two groups. And again, on page 100, sort of in the middle of the page of your textbook, where it says, is the test significant? And it will let you know. If the significance two-tailed is greater than 0.05, then the difference is not significant. If it's less than or equal to 0.05, it is. So we've got a significant difference here, which makes sense. I surely would have a much more negative feeling about zombies if they had chased me. And then the mean difference is just taking 7.42 minus 12.75. So people who have been chased by zombies on this questionnaire were 5 points lower. Their attitudes were 5 points less positive. So there's our data. And I just cut that and pasted it right in here to our statistics. So what are we going to do? We will reject the null hypothesis. Our obtained P of 0.014 is less than the critical P of 0.05. So we reject the null and conclude that people who have been chased by zombies have less positive attitudes towards zombies, the mean of 7.43 and the standard deviation of 4.97. Remember, that's coming from right here, the top descriptive statistics. Compared to those who have never been chased by zombies, their mean was 12.75 with a standard deviation of 6.03. Right, again, right here, the second line of the descriptive statistics. And then our T with 28 degrees of freedom was negative 2.614. P is equal to, the equal sign in, 0.014. And that's how you do it. Again, if I had told you to test this at the 0.01 level, alpha is 0.01, well now this 0.014 is greater than 0.01, and so you would actually accept the null because our obtained P of 0.014 is greater than the critical P of 0.01, and in that case we would say that there's no difference in attitudes between people who have been chased by zombies or not chased by zombies. All right. As always, please send me an email or feel free to stop by my office hours if you have questions, and good luck on the work for this week. Thank you.